All right, we're going to get started now. So like I said, today we will be hearing from Earthwatch's Chief Scientist Dr. Cristina Eisenberg about wolves, bison, and fire, the ecology of repatriation. Cristina is also the lead scientist on the expedition restoring fire, wolves, and bison to the Canadian Rockies, and during today's webinar, she will discuss how these three forces of nature shape the landscape. Very shortly, Cristina will begin her presentation, which will last about 40 minutes. After that, we will use the remaining time for Q&A. You can submit your questions through the chat function of the webinar or the Q&A feature. And feel free to enter your questions while Cristina is talking or at the end of the presentation. We'll try to get through as many questions as we can, but with 20 minutes left for questions, we'll just see how that goes. Also, if you have friends that weren't able to attend today, we're recording the webinar and we'll be uploading to YouTube, so keep an eye out for that link and you can share that with your friends. All right, without further ado, here's Cristina Eisenberg. So Cristina, it's over to you now.
So I am looking for my screen so I can share it.
All right, I'll stop sharing our end. All right, so we see that there we go.
Yes, just a minute. Hello, everybody. It's good to be here. Today I'm going to talk about the project that Earthwatch has in the Northern Rocky Mountains and on which I've been the principal investigator, also called the lead scientist, since 2006, and it's been receiving Earthwatch funding since 2014. And I'm going to focus on relationships in this talk between wolves, fire, and bison, certainly, which are really key ecological forces, but as or more importantly, between people and all the people involved in the stories on this landscape and how that affects the science that we do today. I'm dedicating today's talk to Narcissus Blood on the left. He passed away about 1.5 years ago, and the partnership that I have with the Kinai First Nation would not be taking place if it weren't for him. I owe so much to him, and he was a great mentor to so many people, including me. The image on the right is of my two mentors, John Russell and Paul Dosher. John Russell is an eminent Canadian, was an eminent Canadian conservationist. He passed away last fall, and a major ecologist specializing in rangeland health and wildlife. And he took me under his wing almost a decade ago, and he's on his land right there. Our study site is in the background. So his family homesteaded the area immediately outside our study site, which is Waterton Lakes National Park, one of our study sites. Paul Dosher, he's the person in the black shirt. He is also a mentor of mine, and he's currently battling cancer. And he's a rangeland ecologist and an expert on ecological restoration. So this presentation is dedicated to these three mentors who have, I wouldn't be doing the work that I'm doing without their influence. We're going to talk about the anthropocene disruption of natural processes, what that means, and the impacts of that. The role of traditional ecological knowledge. Restoring the prairie with fire, wolves, and bison, also called the ecology of repatriation. And we're going to talk about what repatriation is and why it matters. So welcome to my office. This is our study site in Waterton. This is a metaphorical image. This is me going into the field last September on a stormy day. And really, this image represents what I do, my job at Earthwatch. I lead the science on a global research program. And right now, we have some pretty stormy times ahead politically in this nation. big challenges to conservation here and globally. And my job involves to staying my course, basically, boldly going forward, keeping hope going, being innovative, and helping support research in nations all over the world that are dealing with some of the same issues that we're dealing with in the United States. I've written several books about food webs, carnivores, and ecosocial impacts on them. The Wolf's Tooth, published in 2010, The Carnivore Way, published in 2014, Taking the Heat, which is a book about climate change and wildlife that I'm in the process of completing. All three of these are for Island Press. And I'm also starting work on a book on bison repatriation called Bison Homecoming. So our planet is at risk, and I'm going to present some of the ecological and ethical perspectives on what this means and how we can address it. So science is central to all of this, but in addition to the science, there's the ethical component. And that is equally important to incorporate when trying to figure out how we're going to live more sustainably on the planet. So the Anthropocene epoch, Anthropocene means the age of man, is linked with this massive wave of extinction. So today we have 7.5 billion humans, with 8 billion projected to be living on Earth by 2020. If you want to see something pretty horrific, go explore the link that's on the left-hand side of the screen. It's the World Population Clock, and it shows the human population on the planet growing by the second. And at the same time, it's accounting for human deaths that are reported. So it's a pretty alarming link, but I think everybody should check it out. Scientists predict that 35% of the species on Earth will be extinct by 2050, 50% will be extinct by 2200, and that humans are the primary driver of what is now known as the sixth extinction. So the previous extinctions were all caused by things like asteroids hitting the planet, things that just happen, cataclysms. This is the only one that is directly related to humans. So welcome to the Anthropocene. It's a man-made world, a world that's characterized by man or humans over nature, command and control management. So the idea that humans can control everything, including everything about the natural world. This image is of something called desertification, and that is where humans have overused a piece of land by cutting down all the trees, planting too many crops without giving the land a break. Something like a drought comes along and the land no longer has the resiliency to adapt to that. And so this is what you get. So what does the Anthropocene entail? Well, the Anthropocene began roughly around the year 1750. It's directly linked to the industrial era. I'm writing a lot about this in my climate change book. So what we did was we killed all the predators, and we did this globally. So this isn't any particular nation, it's every nation did this. We clear-cutted forests to create agricultural land, basically, and to use the wood for economic reasons. We stripped mined for coal. We drained wetlands to put in more farmed lands. And we eliminated fire because that presents what we perceived as a threat to humans. So a lot of these things made perfect sense. We wanted to eliminate threats to humans, like big creatures with sharp teeth and claws, and fire. We wanted to drain swamps so that we could grow more crops to feed the ever-growing number of people. Today we know that this has created a disaster, and we're trying to figure out what to do about it. And one of the possible answers is to go back to a more traditional way of knowing and of living on the earth. And this is the way of knowing and living on the earth that predated the Anthropocene. So it's the wisdom that indigenous and local people acquire by living on the earth, very closely connected to the earth. And this is an image from one of our Earthwatch projects. We have many projects in Africa and worldwide, and the project for which I'm the principal investigator in Canada, where we incorporate traditional knowledge at Earthwatch as much as possible. It's rooted in a specific landscape and is based on the fact that every single thing, the human and the non-human, is connected. So this braids together relationships between plants, animals, the earth, the seasons, and all kinds of people. It's based on the premise that human and non-human components of the natural world are inseparable. It links ecology to spirituality and cultural values. So not only are humans and other animals inseparable, how we think about the world, the science of that, the spirituality behind that, and our culture, all of those things are also inseparable. So let's compare traditional knowledge and Western science. And Western science, by the way, originated about 2,000 years ago with Aristotle and Plato. It came out of philosophy, but it didn't really become the kind of science that we do today until, now this is really interesting, about 1750, sorry. So it coincides, the development of Western science coincides pretty exactly with the development of the industrial era. So traditional knowledge, it's mainly qualitative. Western science is mainly quantitative. TK is data collected by the community. Western science is data collected by outside experts. TK has long time duration in a specific site. Western science is short duration studies. So the average research project is about 2 years. TK is part of daily life and subsistence and spiritual practices. So it's embedded in people's lives, versus Western science involves Aristotelian hypothesis testing. And we create these hypotheses in our labs, not usually while we're out there measuring things. TEK is holistic. Western science is linear. Things are presented in black and white terms. This is true, this is false. TEK is matrilineal. Western science is patriarchal. So here's the landscape where I work. And this is a collaborative research project. I'm one of many people that are intrinsic to this project. It's Waterton Lakes National Park, Alberta. It is a really special site. It's a UNESCO World Heritage Site, a biosphere reserve, and an international peace park. I don't know of any other site that has received those 3 separate designations. The United Nations designates places as World Heritage Sites because they consider them absolutely essential, their conservation, to the welfare of all humans on the planet. So why did they do that to Waterton? Well, the picture on the bottom is part of why. And actually, these 2 images are of our study site, where Earthwatch volunteers and myself and my co-investigators and our field technicians collect data. So these are not touched up images. It really does look like that. It's this incredible landscape. But it didn't get that UNESCO World Heritage Site designation just because it's pretty. What you're looking at is about 3%, well, just about all of the short fescue grassland left in Canada. So only 3% of what used to be there in 1850 is is still existing there today. Short fescue grassland is a biodiversity hotspot. It's a short bunch grass prairie that supports some really important species that, and it provides the best habitat for them. So here's the context of what we did to this place and many other places in North America. And if you change the players here, you can apply that to a lot of other places globally. So it's called dewilding. So the bison, fire, and the wolf are essential forces of nature. They are based on traditional knowledge. These are the forces that kept that ecosystem healthy. The first people, Blackfoot, Kinai First Nation in this particular part of North America, and other tribes recognized that these were sacred forces to them. They needed them present and they honored them because that was what held their world together. That was their science. So when European settlers came in the mid-1800s in this particular landscape, the first thing they did was they got rid of bison, then they got rid of fire, and then they got rid of wolves. The reason they did this was political and economic. Some of it was greed. Some of it had to do with controlling the First Nations. And some of it had to do with creating a lot more elk so that people could hunt and eat elk. And also it had to do with the ranching industry, which was starting back then. So to create places where you could stock the range with cattle instead of bison. This is what we did. This is a government image from the US Fish and Wildlife Service. It's in the National Archives. Those are bison skulls. So this was, I don't even have words to describe how horrible what we did was. And our ethical values of the time enabled us to do this with regard to wild living creatures. Now here's the science that I do to measure what happens when you de-wild a place and what happens when you re-wild it, and what are some of the other factors that are involved in these relationships. So I'm going to take Waterton Lakes National Park and the surrounding region down to its fundamental forces. The images, the three images on the top, you have a wolf, and that's a wolf from my study. That is actually a trail camera image. An elk also from my study. That's a GPS collared female elk, and aspen. So wolves, they primarily eat elk. That's their favorite food when they can get it, because elk are a lot bigger than deer. There's a whole lot of them, and they're highly nutritious for wolves. And elk, when in winter, they switch from eating grass to eating aspen. So the idea being that wolves control elk, and elk subsequently have less impacts on aspen. So the arrows that go, the bottom set of arrows that go from the right to the left show that wolves exert pressure on elk. That then creates a beneficial relationship with aspen. Conversely, if you eliminate wolves, the elk explode in number, and they eat all the grass and they eat all the aspen. Basically, they damage their habitat. So if you have a wolf in present, that's the top-down perspective. You have a much more, a healthier ecosystem in which energy is cycling more vigorously. Bison are a lot bigger than elk. They're about twice the size of an elk. And they are not so easy for wolves to kill in large number. Bison are also known as ecosystem engineers, and you can see the citations for the science appears on the right hand of the screen. So what bison do is their urine is nitrogen fixing. It's like the fertilizer that you put in your garden. So just by being in a grassland, bison are improving energy in that system and increasing resources and improving soil quality for myriad other species. Fire can have a similar effect, and this is a very fire adapted system. So fire increases the energy cycling through that system and makes it a healthier system. And so these are bottom up inputs because they affect the soil. The environment, that's our study site in September. That's what it looks like. So summer there is really short. The environment is precipitation, the resources available that come from the sun and from the rain that falls that enables plants to grow. So when we have healthy plant communities that includes grass and aspen, it's a combination of those top-down effects from something like a wolf being present, and the bottom-up effects from something like bison and fire being present. These are called trophic cascades. Trophic just means food. Cascades mean these relationships move through a food web like a waterfall. So to put it more plainly, the image on the left is a system, the same ecosystem, no wolves present at all. The image on the top right is the same ecosystem, and that's a thicket of aspen. And there are tons of wolves present, about as many as that particular site can hold. The image on the bottom is of our study site in Waterton about 6 weeks after it burned. So why do we need fire and why do we need wolves? Well, without them, the trees on the left have not burned when that image was taken, hadn't burned since about 1850. And the trees on the right behind me, there's wolves in that system, but those trees had burned about 10 years before that image was taken. So wolves and fire, in my doctoral work, I found they work together. And this image illustrates that even more compellingly. This is an image from Waterton Lakes National Park. It's taken by a Reconyx trail camera. It's a wolf. This image is located very close to a wolf den that's been in use for many years. Now, the idea put forth in places like Yellowstone is you put wolves back in the system and everything is fine. They save the world, right? They keep deer and elk from mowing plants down and browsing things to death. But look at those aspen in the foreground. What do they look like? They've been hammered pretty hard by deer and elk. And in the other picture that I had of a trail camera shot of the wolf, that was from the same site. And that was a wolf and there was a carcass at that wolf's feet. I cropped it out of that image. But so they're actively preying on deer and elk, and that's not saving these aspen. Why is that? Well, this site also hasn't burned since 1850. So I started to see that wolves need fire, but what about bison? Well, that's what we're looking into right now. This is the Earthwatch project that we started in 2014. It builds on the work I did for my dissertation and postdoctoral studies. It has become quite a large collaboration. Initially, it was just me collecting data as a first-year PhD student, and now I think it's been 11 years. This will be our 12th field season. It's morphed into a beautiful collaboration with the Kinai First Nation, with scientists from other universities. It's really exciting. So my co-investigators are Curtis B. Edson from Michigan Tech and David Hibbs from Oregon State University. The project staff, in addition to the scientists, are Chris Anderson, who's the lead technician, Elliot Fox, who's a Kinai tribal member, and Diandra Brucehead, she's also Kinai, Monica Barta, and Alex Shade, he's also Kinai. And Chris Anderson is a master student, and I'll be speaking briefly about his work in a little bit. And the map shows where our study site is in North America. The background and objectives. The Canadian federal government, remember this is a biosphere reserve. For some strange reason, unlike in Yellowstone and other places, these aspen had been taking over the grassland over the previous 50, 60, 70 years. There had been steady encroachment. And the thought was bison would keep the grasslands open. This is very well documented by horning up the young aspen saplings and shrubs. And they don't really eat aspen and shrubs, but they tear them up with their horns. And that prevents these trees and shrubs from taking over the grass. So between fire being missing and bison being missing, these aspen, have been really taking over, even in the absence of wolves. So again, I want to emphasize that the world is not so simple, and it's not just a wolf-dominated system. It's a lot of these elemental forces working together, which is what the First Nations and Native Americans knew all along. It's just taken Western science this long to catch up to that knowledge. So the park really has as its top priority restoring that grassland. It's precious. So they decided to set these large prescribed fires, which is an amazing thing that they're doing. It's ecological restoration, which is the science basically of restoring degraded systems, making them healthy again. Priorities are to reduce the aspen, restore the rough fescue prairie, and restore senescent or aging aspen stands. So by burning up these stands, it'll make them resprout, and it'll create a more complex canopy structure in them that provides better habitat for birds, increases biodiversity, and insects and many other species. This is a completely fire-adapted system. The images on the left were taken right after these prescribed fires. And by the way, as I give this webinar, the park is reburning this site that's in the lower two images. That fire is supposed to be taking place right now, like right this minute. And it's supposed to be 2,200 hectares, which is, I think that's about 6,000 acres in size, so it's huge. So images on the left were taken right after the fire, as in like a couple days or a day after the fire. Images on the right were taken about 6 weeks after those fires. So you can see the severity of these fires. And these are the same sites. And you can see how that whole system responds. In the background, you see this herd of elk during the fire that's depicted in the image on the bottom left. Those elk are used to this, and they just run around in circles a little. And then when I visited the fire sites immediately after the fires, well, about 48 hours later, there are already things sprouting. That's how rapidly the system responds, and there's already elk looking for new sprouts, because the elk know that this is like fertilizing the whole system. So you burn it and everything goes crazy. And what you get are fields of wildflower and grasses that already 6 weeks later are up to your thighs. It's unbelievable. So this is a friend, my friend John's family photograph, and it shows our study site, and where you can see, he said, this is what it used to look like, and he pointed out how a lot of what we're seeing behind that horse is now covered by aspen. And so the aspen, even with these fires, continue to expand. This is the study site context. This is an image of the same area that you saw that was all blackened by the fire. So those little specks that look like ants, those are elk. This has one of the highest elk densities recorded in North America, about 1,000 elk right now in that park. This is their winter range, so they come here to spend winter because the snow doesn't get very deep. It does snow there quite a lot in winter, but it never gets more than 3 feet deep. It's really rare. And so it's a grassland matrix dotted by aspen and shrubs, and the elk, they eat grass until about June, and then they start switching to eating aspen and shrubs because the nutritional value of the grass has declined at that point. And the aspen is highly nutritious for them. It's like a superfood. This is that same site, and these are captive bison that the park has had in there since about 1950. It's not enough to just have captive bison, because bison are animals that migrated several hundred miles. These herds made these big movements, and so captive bison can't have the same impact of wild free-ranging bison. This is the fire history in Waterton Lakes National Park from 1989 to the year 2001. The red dots are and polygons are wildfire, and then the yellow, those are the prescribed fires that have been set in the park as of 2011. And we have more recent fire maps than that, but I wanted to give you this overview. And here I am in the field with Dave Hibbs, who was actually, he's my co-PI now, he was my PhD advisor, and he's a wonderful mentor. And Scott Murphy, who is probably crazy busy right now with that fire that they're in the process of setting in the park. He's the park fire ecologist, and he's a virtuoso at setting fires. These big fires, it's really an art to set them, and to set them in a way that the fire does what managers want it to do. So we're out in the field last fall asking big questions about the fire and its impacts and what are next steps for management. And it was a great day of field for the three of us. So what do we do? In our study, we measure what the wildlife are doing and how the grass and the aspen are growing. So it's a multi-trophic study. Trophic, recall, means food. So it's looking at all the different levels of components of that food web. And this involves gathering a ton of data in the field. And I'm going to talk about the traditional data that we gather. And in a little bit, I'm going to talk about the very high-tech data that we're gathering as led by Curtis Edson, the co-PI on this project, who's a geospatial engineer. But we are doing a lot of leave no trace data collection. We are putting in about 100 kilometers of track transects, where, in fact, I'm going into the field in 5 days to start that work, and we do that in the early spring. We measure the fire impacts in the aspen, including how tall saplings are, how much they're being browsed. We also monitor wolf activity in the park. So we, in established transects in wolf high use areas using traditional wildlife tracking. I've worked with radio collars on wolves before, and at this point we prefer to use non-invasive methods for a variety of reasons. They're more humane, and also to improve the survival of these wolves. So these are all pictures of volunteers, Earthwatch volunteers. This is what people do when they join us in the field. It's an incredible adventure. And it's also this very deep immersion in that landscape. And so what we do is we're really taking the pulse of that whole ecosystem, but quantifying this in a way. I'm not presenting our results in a statistical way today, but these data that are collected by Earthwatch volunteers who we're with all the time. So they're part of our field crew. Lend themselves beautifully to the most sophisticated multivariate statistical analyses you could imagine. Hundreds of models they support building, and analyses that are very in-depth that look at how all these different components of the ecosystem work together to affect things like what elk are eating or how the aspen are growing. This work would not be possible with volunteers. Before this was an Earthwatch project, I have always used volunteers for two reasons. I need the help. I've always had field technicians, but it really is a lot of data that needs to large data sets. And secondly, for outreach, because by getting people involved, there's learning by doing. And in order to truly understand the conservation issues we're dealing with, things like wolves and fire and bison, you have to walk the walk. And so you can see that these people are walking the walk. So here is one of my favorite groups of Earthwatch volunteers. This was taken last summer. And the gentleman in the middle, his name is George. He's 90 years old. I forget how many Earthwatch expeditions he's been on, maybe 50, maybe 60, maybe more than that. This was actually his last one because he had developed some health issues. And it was a deep honor for me to have been in the field with me and learn from him. So his first degree was in horticulture, and he was able to tell me, and he's from the UK, and he was able to identify all the plants, all the shrubs, tell me everything about them with, because he was such an expert at horticulture. And he hadn't used that knowledge in his professional life. He went on and became a very successful businessman. But he was a tremendous gift to our project. There's this fellow holding this big stick, and that's Chris, our master student. But right next to him on either side are two ladies who are members of the Kinai First Nation, and they are teachers at the high school, and they are community fellows on our project. So that means that the tribe gave them fellowships so that they could join us in the field to learn about the ecology of fear, what wolves do, what fire does, and what the role of bison might be, and take that knowledge back to their classrooms. And I'm going to talk a little bit more about that, but they are very, very special members of our field crew, and it was such a pleasure to be in the field with all of them. And there is a young man in the yellow is an Earthwatch volunteer who had just turned 18, and he wanted to be a biologist, and so he joined our project so that he could see what it was like to be a biologist. And boy, we showed him with miles of bushwhacking and wolf tracking and all sorts of stuff. So it was a really great team. So our findings in a nutshell are that these fires cause the aspen to sprout, and that elk, even that many elk, as you saw, that are in that system, was insufficient to prevent aspen from encroaching on the grassland. Aspen cover increased during the previous 10 years. The elk avoided areas that had the highest sprout density, the most foods, the thickest shrubs, and the highest where the fire had burned with most severity. And we think this has to do with two things. Immediately after the fire, the nutritional content of the grass goes up for a couple of years. But also, those thickets of aspen was where we would find that wolves would run elk into and kill them. The elk would trip and stumble on the thick undergrowth there, and the wolves, that's where they would become vulnerable to wolves. So we found, Earthwatch volunteers found a lot of carcasses inside those stands. It's really interesting. And we found that bottom up and top down effects work together. So it's not just wolves driving this system, but what happens from the bottom up is as important. So fire, and that missing piece could be bison. That's, you know, what we recommend is really considering the role of bison in this system. So we began a Kinai First Nations partnership, which was suggested by Narcissus Blood after reading my book, The Wolf's Tooth, and joining me in the field. He said, hey, you should do this on our land. So the Kinai have tribal timberlands right next to the park, and I will show you what that looks like in a subsequent image. And they invited us to explore the possibilities of collecting data on their land to help them with their natural resources management, using the same methods that we've been using in the park. And so this is a collaboration that was envisioned by Narcissus as involving Kinai land managers, tribal field technicians, students and teachers, Earthwatch volunteers, and members of the community. And so here we are scoping that site. You can see us in the fire image right after a fire has occurred, and exploring these possibilities. The image on the left, far left, is of the tribal lands, and you'll see a few more images of that. So the Kinai First Nation, Kinai means many chiefs. Their other name is the Blood Tribe, by which they were known for many years, but they're reclaiming their language. And the name Blood Tribe was given to them by the Cree Indians. They are members of the Blackfoot Confederacy. So the Blackfoot Confederacy has several bands within it, and the Kinai are one of them. The Blood Reserve is in southwest Alberta. Here's a picture of Narcissus Blood, who was a member of the Tribal Council, a highly esteemed teacher, mentor, leader. He's a filmmaker and an Oxford University scholar. He was one of the leaders in the repatriation movement. Repatriation means returning that which belongs to its native land. So repatriation can be applied to the concept of bison returning, or returning First Peoples artifacts like medicine bundles that are sequestered in museums to the tribes that they belong to. And the image on the bottom is of the sun dance. So this is one of the tribes, one of the few tribes that never stopped doing the sun dance, which is a very powerful cultural and spiritual practice for them. At the same time as Narcissus is inviting us to think about doing work on their land, things have started moving really fast for bison. So in Banff National Park, the Bison Belong initiative was launched around 2014. By 2016, the IUCN, which is the International Union for the Conservation of Nature, had their bison specialist meeting in Banff, and those are chiefs of tribes signing the bison, the Buffalo Treaty, which was drafted by Leroy Little Bear as part of the ENI, which means Bison and Blackfoot Initiative. And in 2017, bison were reintroduced in Banff. And you can look that up online. There's videos online, and Earthwatch is producing a multimedia piece about the bison reintroduction. And they're being held in the backcountry in a soft release pen, which means they're being acclimated to the site, and then will be released into the wild within the next year or so. So here's the tribal land. It's called the Blood Timber Limit. It's that little notch that you see in Waterton Lakes National Park. Below the border is Glacier National Park. 2,000 hectares. It's basically elk range, and it's also a historic bison range. So bison used to winter in that area. Today it contains all the large carnivores present historically, including wolverines and lynx, and of course wolves. What we will be doing in starting this June is surveying the elk winter range in the timber limit, and for 3 years looking at all of the different components of that food web, the grass community, the aspen, putting in traditional track transects to measure what the elk and the carnivores are doing. Same methods as we're using in Waterton, however, informed and looked at through a traditional knowledge lens. So the question is, what ecological restoration activities will maintain the blood timber limit as a healthy biodiverse community that sustains development, recreation, and cultural, spiritual practices and natural processes? To that end, the Kinai Environmental Protection Agency has been hosting summits. And these summits are gatherings where tribal members and scientists from outside and scientists from inside the tribe present the work that they're doing and discuss the best path forward. And here is a field trip from last year's KIPA, as it's called, summit that I co-led with Elliot Fox and others onto, and that's the timber limit that you're looking at. We're learning from each other. Images here on the bottom left, that's Barb Johnston. She's the chief ecologist in Waterton Lakes National Park. An image on, at the top image is a Kinai elder. And we're all learning together. We're sharing our stories. We're trying to wrap our brains around a new way of looking at how to make this a healthier landscape. So as I explained, that's more of the timber limit. You can see how beautiful it is. And to survey it, that's all the elk winter range in there is what you're looking at. It's very similar ecologically to what's in Waterton. To help restore these natural processes and collaborate with Waterton in adaptive management that includes fire and bison. So we're combining methods, traditional ecology, old school silviculture, for example, and wildlife tracking with traditional knowledge and cutting edge technology. And this is where Curtis Edson comes in. That is a high level drone, the kind that's called a UAV, the kind that flies like an aircraft. So you need to register it with the government and fly and get a license to fly that. It's not a recreational type UAV. A Trimble GPS, that is an $11,000 GPS unit, that all of these do mapping at an ultra-fine scale, as in less than a meter. So super accurate images that are multispectral to map these plant communities, combined with the messiness of gathering data in the field. Here I am with a field crew, most of those are volunteers, and spending time in the field with elders, learning about what we can do. What we can contribute are training Kinai students on data collection, and on the image on the left you see 2 Kinai community fellows from last summer, and these are young people who are learning. Providing jobs for tribal members, supporting traditional knowledge, and providing the tribe with data. So all the data collected on our project belongs to the tribe, the data that's collected on tribal land. And also sharing it with the IUCN to manage natural resources and support bison reintroduction. What the Kinai can contribute to us are traditional knowledge, Kinai field technicians who are deeply connected to that landscape, and data that can be used to deepen our research in the park. So we have launched at Earthwatch the Kinai Community Fellows. Last year we had 4 teachers and high school students, 2 members of the community, a 10-day immersion in the field, funding from multiple sources. So it was a pilot year. This year, We have 22 Kinai community fellows joining us. Next week, I will be in the field with, I think about 16 Kinai high school students and 4 Kinai high school teachers. It's going to be incredible. And these are images from the field from the fellows that we had last year. I can't wait. I mean, to me, this is, I think, more important than anything else we're doing on this project, because it's how we are integrating this into the community and creating future leaders. So this is us at the end of the field season, last day of the field season last year. And these are our Earthwatch volunteers and some of our field technicians and me. And we're jumping for joy. We love this work. And with that, I will take any questions that anybody has about this.
All right, thank you so much, Cristina. That was an awesome presentation, and we certainly have quite a few questions that came in. A couple that both touched on the same thing. Fernando and Stephen were wondering, what has the response been to your research outcomes from the ranching community and other stakeholders in the area?
So the Russells are ranchers. And the ranching community is very supportive of our research. We have built partnerships with them over the years. I should say I have built those partnerships because my co-PIs have not been involved in that. I come from a ranching background. My family's ranching background goes back a couple hundred years. And so in my family ranched in areas that had wolves and found that the wolves were not killing a lot of any livestock to speak of. And so they coexisted with wolves. And this was like in the 1920s. And so and I also hunt. And so those traditional rural Western values, they're in my blood. And so when I sit down and talk to ranchers, we have a conversation. And I don't communicate like I'm the scientist from this university and I'm here to tell you what the right thing to do is. We have conversations. And so I've had many ranchers volunteer on our project over the years.
Awesome. Mary was wondering, how are the community of Western scientists responding to your research? It must be pretty challenging to them.
Actually, the research that I do has been published in top-level peer-reviewed journals. I got a PhD on this work from the highest-ranked school of forestry in North America. And I'm highly respected in the scientific community as an individual, and our research is highly respected in the scientific community. So what I did not present was all of the analyses that we've done and all the statistics and the research design, but all of that is best quality. And so I walk that walk too, and what I do is I integrate them both.
Awesome. Historically, how frequently did your study site burn, and how frequently are you recommending the park reburn?
So this study site was burned by First Nations as part of their stewardship practices going back thousands of years. It had to do with improving their hunting and also improving habitat for bison. They understood that if you burned the grassland, the bison would show up the next spring. So it's thought that the site was burned quite frequently, and they were low severity, light fires. And these were fires intentionally set by Indigenous people. The large catastrophic stand replacing fires, there's a raging debate in the forestry world among scientists about how often they occurred, but I've seen accounts from maybe every 700 to every 350 years in this system. So those are different fires, and what the park is trying to do is reset the historical clock to something that resembles more closely what historic conditions were. And you can't just do that with one fire, because if fire has been suppressed for so long, then you have to do it in increments, and that's what the park is doing with these repeat fires. How often should they happen? Well, without bison in that system, they're going to need to happen every 3 years. That's what my colleagues and I recommended. If you add bison to the system, because the bison improve the health of the grass and also keep the aspen under control, we're thinking, and this is, these are just ideas, we really have to test this in the field because every site is different. We're thinking that these prescribed fires could happen a lot less often.
Great. We have time for just one more question. This one is, have you ever considered asking research questions similar to the ones you are asking in the Northern Rockies in other parts of the US or world? I am sure there are similar cases of keystone predator roles in trophic cascades with different species and ecosystems that need attention.
Well, yes. So first, at Earthwatch, we have many projects, such as Jake Goheen's Lion Project in Kenya that asks very similar questions and are looking at the relationships between apex predators, lions in that case, their prey, which are zebra in that place, grassland health, which contains a lot of the same types of grasses as are in Waterton. The species are different, but ecologically they're the same type of grass. That's just one example. We have a project in Mongolia that also looks at these multi-trophic relationships in Mongolia. It's Argali sheep and lynx and wolves and sheep and domestic sheep. However, I am starting a project in the UK in the Scottish Highlands on rewilding the Scottish Highlands to collect baseline data to examine a very large conservation property to which wolf return has been discussed. So what I will be doing is collecting baseline data, and it's an area that has red deer, which are elk. That's what elk are called in the UK. So we're doing this a lot. In North America, I've done work in Colorado on rewilding. And the bison piece, it's in the early stages, this bison repatriation, but I expect that work will expand in North America as well.
Great. Well, thank you so much for this amazing webinar today, Cristina, and thank you everyone for joining us. If you are as excited about this project as we are here at Earthwatch, you can sign up to join Cristina and her team in the field in Waterton Lakes National Park. We have several spaces available in 2017 teams and 2018. So you can just visit earthwatch.org and look for the project title, Restoring Fire, Wolves, and Bison to the Canadian Rockies. And also keep an eye out for this YouTube link to appear, and you can share this webinar with your friends. So thank you everyone for joining us today. And thank you, Cristina.
Thank you, it's been a pleasure.